The brain's challenge is essentially a processing challenge. Deconstructing this challenge, we see that there are a series of sub-issues that must be understood. Essentially, in order for the reading process to generate a comprehensible simulation of language, the brain must process incoming visual information, the code, into an assembly of auditory memories according to the instructions and information contained in that code and according to previously learned procedural instructions about how to process that code, and do all this fast enough for attention to the processing involved to stay engaged. More specifically, this means recognizing graphemes, and for more advanced readers, morphemes, and disambiguating, by the way, I'll come back to that word more later, the right correspondence between those visual elements and the naturally learned speech code underlying spoken language. This process must result, at least initially during the learning to read phase, an internally heard, virtually spoken word that can be recognized and comprehended. And as we will soon see, this has to happen incredibly fast.
The fundamental differences in sort of the human equivalent of clock time can be very small, but if the processes that are drawing upon them are really essential and they're really being called upon over and over and over again, these differences that are very small to begin with end up being very, very large and have tremendous downstream effects.
The problem with automatization is that at any step, if you've got a slowdown step, if any piece of that enterprise has a block, or you can't hold enough of the information, the whole house of cards falls apart.
So there's not a lot of time in there to process the information that you're looking at, yet it's still interesting that, as I said, the eyes are being influenced by how hard or easy the word is to process.
So the building blocks are that there's a distinction, an ability to recognize differences in sound in time. That's important to be able to, in the technology world they call it the analog to digital converter, right, where we're slicing the analog stream into chunks. So if they're not doing that fast enough, then they don't have the granularity of distinction necessary. Then on the other side of that, once they have that, there's a frequency or speed of processing that's necessary to assemble inside the mind to create the virtually heard stream in the reading process, and that any one of these things can cause a bog in processing that causes the stutter that breaks down reading.
Right, right. I think, hope we can put your words in there. That sounded perfect.
You wouldn't have to have much of a fault in this machine operating with high speed and this incredible processing efficiency that's required to begin to see somebody be a little slower at it or a lot slower at it.
Yes, and in addition to the underlying sound processing issues we talked about earlier, wouldn't the trouble also be related to the confusion and correspondence between letters and sounds? In that the more time it takes the brain to resolve the ambiguity, the greater the stress on the system to produce the experience of reading.
Make the representation of those sound parts of words a little fuzzy. And now I'm going to slow down the ability. And also, as soon as you do that, I might say you also have a decline in processing efficiency, the ability to hear something and rapidly translate, do anything with it.
Doesn't the same exact argument apply to the fuzziness between letters and sounds?
Absolutely, absolutely it does.
That's my point.
Yeah, absolutely.
That's a technological artifact, not a naturally occurring soundscape variation.
Yeah, no, absolutely. Well, it is in a sense a technological artifact, absolutely.
Apart from the distinction and processing frequency issues that we're talking about relative to oral language processing, that when we talk about reading, we're talking about something else, which is how all that works in relation to this code.
That's right.
Because on the one hand, we've got these distinct elements, which are required. But on the other hand, before we get to wherever we're going, we've got to assemble them.
That's right, back together.
They have to go back together in some way, in which if there's ambiguity in the distinctions, it has to be processed through in the assembly. So the more that there's ambiguity in between that, the more there's time consumed in working it out.
The truth is that reading is one of the more complicated of the higher cognitive functions, using attention and rate of processing and sequencing and memory and the linguistic systems and the visual system, and it having to coordinate this dance that's going on. And the more complicated the translation from the orthography to the phonology is in a particular language, the more complicated this processing dance has to be within the brain.
C, K, S, Ch, Sh. O, Ow, Ah, Wa, U. M, T, P, A, E, R.
There's a messy, confusing relationship between letters and sounds. We wouldn't let any machine in the world run code like this. And the challenge is that our children's brains have to work through the confusion in that code. They have to disambiguate the relationship between the letters and each letter's range or field of potential sounds in the actual sound that letter's supposed to be making in the word that it's currently appearing. If you were to break down all the bottlenecks to processing involved in reading, having to do with visual recognition and the speed of visual recognition processing, having to do with sound processing and the speed of sound differentiation or phonemic differentiation, or vocabulary. You can break down all the different bottlenecks. And some of them, of course, require more exposure, like vocabulary. But when it comes to pure processing problems, what is it that's challenging the brain most from a point of view of just the processing challenge? The biggest single processing challenge bottleneck for most children is disambiguation. It's working through the confusion in the code in time to keep up with the rate of language production, of virtual language production that's necessary to make a coherent, intelligible, understandable stream of language happen in their minds.